So we'll look at number 2 here. Pam is a disc jockey. Every week she buys 3 new albums to keep her collection current. She currently owns 450 albums. We want to write a recursive formula for the number of albums Pam has, and then we'll write an explicit formula for the numbers of albums Pam has. All right, so let's start with this recursive formula, and it's going to look kind of strange, but let's just first think about what we're going to do here. We're going to have 450 albums that she currently has, and that's what she'll have in her first month, or really our initial. And then she's going to take 450 in the first month. She's going to add 3 albums. And then she's going to take 450 plus 3, and she's going to add 3 more in her second month. And so on. Okay, so now what we're really going to have for a recursive definition is every P sub n, and remember I said that's like the amount at the nth month is what that means, is equal to the previous amount, which is just the amount at one earlier month with 3 added to it. And we want to say that our initial, our initial amount was 450 albums. This is our recursive definition, and it's kind of a strange looking notation for us to get used to. But if you'll notice, the first part of the recursive formula always looks the same. The nth item is equal to the previous item in minus 1 item plus whatever is changing each month, okay, or each year or each day or whatever our time period might be. And then we always list what our initial amount is. All right, now an explicit formula is much more useful to us. So if we write the explicit formula out, our explicit formula for P sub n, we're going to take 450 as our initial amount, and then every month we add 3 more. So let's notice this is 3 times 1 the first month, 3 times 2 the second month, it'll be 3 times 3 the third month, and so on. So in the nth month, it'll be 3 times n, and that's our explicit formula. So let's take a look at one more beneath it. So notice that they start by giving us the recursive formula. A store's sales in thousands of dollars grows according to the recursive rule. The nth one is equal to the previous one plus 15, but our initial population is 40. So let's calculate P sub 1 and P sub 2 using the recursive definition. So if we think about the way this works, all right, our P sub 0 is 40. So our P sub 0 is really the initial amount. Well, I can get the subscript out of there. 40. And then month 1, we're going to take the $40 that was initial, or 40 whatever. I guess, yeah, it's thousands of dollars, it says. So $40,000, but we're not going to write it as 40,000. And we're going to add 15. So that's 55. And then for our second month, we are going to take the initial 40 and the initial 15 from the first month, and we're going to add 15 more, and that's going to become 70. All right, now we can kind of see what's going to happen. We're we're going to see for our explicit formula, take that off, P sub n, the nth one, is going to be equal to 40 is always going to be there. But let's notice for this, it was 15 times 1. For this, it would be 15 times 2. If we did P sub 3, it would be 40 plus 15 times 3. So it's 15 times n for our explicit formula. All right, so let's use our formula to predict the store sales in 10 years. And let's see, were these? Oh, okay, I guess they weren't. I was saying months, but they must be years. Okay, so let's predict 10 years. So P sub 10 is what we're predicting. And we'll use our explicit formula, 40 plus 15 times 10. And that's going to be 40 plus 150, equals 190. All right, and now really that's 190,000 because remember the store sales, what is in thousands of dollars. All right, so let's look at D. When will the store sales exceed 100,000? Okay, so really we want for this amount to be 100 because remember 100,000 is expressed as 100 back here. So we're looking for somewhere that the left side of the equation exceeds 100. So here's what I'm going to do. I'm going to take my explicit equation, set it equal to 100, and solve for n. All right, so this is where we have to remember how to solve equations from earlier algebra courses. Let's remember we want to get n by itself, and to do that we always get rid of what is out to the side first. So since this is a positive 40, we're going to subtract 40 from both sides of the equation to get rid of it. So on the left side, 100 minus 40 is 60. And on the right side, the 40s cancel out, and we still have 15 in. And then remember from algebra, to get rid of a number that's being multiplied by our variable, we divide it out. So I'm going to divide both sides by the 15 that's in front of my n. And I'll just use my little underline feature to show division. So we're, dividing by 15 on both sides. So on the left side of the equation, 60 divided by 15 is 4. And on the right side, the 15s cancel and we just get n by itself. So in 4 years, the store's sales will reach 100,000. So essentially after 4 years, it will exceed 100,000.